Welcome everyone. We'll start our class. I think most of the students are got busy as today it is Sunday. Let's get started. I hope everyone can see my screen. Yeah. Okay, so as you see the title, this course is mainly becoming master into Docker, Kubernetes, Terraform, Helm Chart, Prometheus, Grafana, and ArgoCD. As industry is moving towards these latest tools, and also all the projects are mainly adapting these technological tools. So that's how many students of mine are requesting in-depth sessions on these tools. So that's how this course is developed, and I'm going to give you a complete picture from scratch to the advance. Okay, so like I'll just do a master into Docker and as well as Kubernetes into EKS cloud platform. We are not going to discuss any traditional Kubernetes. We are discussing cloud native Kubernetes and also Helm chart, which is very important for packaging your Kubernetes deployments. And also we are going to learn about the Grafana with time series database of Prometheus and ArgoCD, and finally Terraform. So with this said, we are also going to cover CI/CD, how to do a deployment. So this is main agenda of this course, that what I'm going to cover in this. Okay, with this what you will get benefits. So as I shown you in the syllabus, if you see the syllabus, go to this topmate.io emergency tech ops and you get this card. Click on this card and you can able to see the syllabus here. Okay, so module 1, module 2, module 3, you can see what are all the things I'm going to cover in this module as a step-by-step sub-modules. Module 2 and module 3 is Terraform infrastructure as a code. Module 2 is the Kubernetes. Module 4 is the continuous delivery with CI/CD. Module 5 is the monitoring and capstone projects. 3 capstone projects we are going to discuss in this. Once you have completed this course, you will get repositories of capstone projects. In this capstone project, everything will be involved, like deploying in a scalable e-commerce application by using the tech stack. Okay, so I will be going to give you a task on this tech stack while we're developing this project. And also capstone project 2, implementing GitOps with microservices architecture. So that is similar like your real-time world. And capstone project 3, which is real-time monitoring with alerting of Kubernetes cluster, which real-time based SRE kind of job you can easily understand here with this project. Okay, so all these tech stacks we are going to use in this project. It is very highly important when I come to the project 3. Project 1 and project 2 are actually give you the best understanding about the platform, the best understanding about the tools and connectivity integrations and all. Okay, and the tools you can see here, we're going to use all these tools and you'll get one certification after completing with some benefits. What are all the benefits I'm mentioning here? You'll get lifetime recording access free, and you'll get a detailed notes with everyday lab and 3 capstone project source code as well. And so this is the real-time curriculum. Okay, so these are all the benefits you will get in this course. Especially if you have any doubt, you can reach me out anytime over my WhatsApp. And while you are doing this class practice, if you have any issues, you can contact an admin. We have admin, dedicated admin, who supports on your practice. If you have any issues, so admin will take care of your issues dedicatedly. We will be having a WhatsApp group separately, and on it you can also connect and do your practice. If not, like we have a Discord, it is something like Slack only, and we do have also Slack. Here you can do direct call and you can share your screen and they can do a control, and admin will give you support on your task. So this is the course structure and the things that we are going to do. Okay, as today agenda we are very clear with this course. Let's jump into the some of the technical discussion. So class 1, introduction to the course and also some of the tools. And why do I need to learn this? Tools basically. Why do I learn these tools? What is the importance of this, and why do I, and where should I utilize these things, and how much I can show up myself in interview or into your project, how much knowledge you can show up in front of them. Like you can say you have a 2 years of experience or a 3 years of experience, how much you can. So that is the what main case that we need to understand from this course. Okay, why you have to learn this means now the industry is moving forward orchestration, guys. Okay, simplification I would say. Okay, means previously we have a lot of issues in terms of dev and deployments, not about the DevOps, deployments. So let me give you a use case like in 2009, 8, 10, 11 something. If we do have one application, let me take one application. I'll just take an application logo. Okay, so for example we have any application. Let's say I'm just taking a bunch of applications. You can consider any application in this social media application. If this application is need to run in a production, then developer is the key person first. He developed everything. It is running locally very well. Local in the sense local laptop. Local laptop itself a server. So we will be going to, developer is nothing but he is going to develop some of the IDEs and he will enable some of the services. Okay, like what we do in the server, in the same way in the local laptop, Visual Studio or PyCharm, Visual Code. Okay, like this. So there are some IDEs that the developer is going to set up, and then accordingly they will set up a virtual environment also in this. Then the code can be able to open up on the local host. What does mean by a local host? Local host means a IP address. Which IP address it is? 127 IP address. 127.0.0.0 IP address. We call it is NIC card, local host IP address, or 127 series IP address we call. He will able to open the application with this, and then he will be moving this code towards a GitHub. towards where he is going to place into the GitHub. Once the code placed into the GitHub, the actual challenge is going to begin. Previously, this GitHub also is going to be in the server, into a private server. Let's say it is into the server. So they have to keep into separate central repository, and from here there will be a multiple Linux clusters. There will be a multiple Linux clusters. Ultimately, if you want to deploy .NET services, then it is Windows. If you want to deploy any other services, then it's an option to deploy into the Linux flavored servers only, like Debian, Ubuntu, RHEL, Linux. Okay, moving this code from this source code to this server. So we have a two servers here. One is staging and one is production. So this is staging. Staging and the production. This code is going to package first. Code has to package. This activity is completely gonna be a Linux administrator, and he will be doing this code as a packaging and then extracting and running inside the staging. And then the manual testers come into the picture and doing the manual testing on the staging environment, then the writing the reports and all, and then this code is moving into the production. To get done this work, it is going to take at least 2 to 3 months with single feature or a small amount of features to be done and released into the production. It is taking a longer time. Even that time, the process of integrating agile methodology, sprints, and working in iteration modes or came into the picture. Even though you are working on iteration mode, it is taking a longer time. Iteration mode, agile mode actually integrated where? In terms of development, not in terms of deployment actually. Then when the development is actively happens, then we have to check the results as well, right? So that's how ops side also it is gradually integrated and it's become agile method deployment side as well. So how the your features are developed, then accordingly you have to see the output, right? You are deploying as speed as your iteration is completed, and lot of manual work here. So you have to take a downtimes, moving, testing, and all these things. The simplification here, see, automation is not there. It's a very raw traditional method. These are our traditional methods. Where you can see these all you can able to see on the data centers, not on the cloud. A cloud is not there at the time. You can able to see on the data centers. So then the Jenkins came and it just created some good automations in between of the traditional movements. Okay, so this is how previously it was happening, but now the tools came and Docker created a big impact into deployment side and development side as well. So what kind of impact it created actually? If we discuss, lot of impacts is created. Now I have a application for example, and that application I want to deploy into a server. I have a, let's say, a server. So this server is there and I want to deploy into this server this application. So this is a single solution application, fine. If I have one more application which I want to deploy into the same server, I want to deploy two services into the same server. It is possible, but it is not lightweighted. It is not lightweighted. If you are running this application with one port number, if you are running this application with one port number, yes, it is works. If you are running many applications into the single server, yes, it is works. but how much your server is capable. And all of a sudden, this was something gone wrong, and you want to move this application into another server. You want to move this application into another server. How how easily you're going to do this? No, it's not easy that much. So the moving an application from one server to another server is not that easy, because this is a code you are deploying here and running here. If you want to run it here again, you have to do the package and do and deploy here and run it. So these are some of the common issues I'm talking. Now when talk about the Docker containerization, mainly we have many tools, RKT, LXT, LXC, LXT, and many other tools, Podman and all, in terms of containerization. But why a Docker become a popular in the market? Why Docker become a popular in the market? Because it is having a lot of advantages, like simplified containerization, packaging. Now let me tell you. If you want to deploy an application and do a test, what do you want to do a test? For example, you want to do this application is working in Chrome browser, it working in Firefox, or it is working in some another. Okay, in that case what you have to do, you have to install one server for Chrome browser. I'm just giving an example. And then you have to go for Firefox server, and then you have to go for some Edge server. Okay, you have to do it Edge server. Okay, you need to set up these three servers and deploy this application here and here and here and test it. Okay, when you want to do a testing of one application into the three web browsers, you need to set up a three servers. So your hardware is costing, right? So how can I simplify it? Hey, why you are taking this three? We can just enable hypervisor or a virtualization into one server and make it use. Okay, this is the one case. Now what I'll do, I'm going to use the same server and I enable virtualization or hypervisor. And top of this, and again I have to go with an operating system, and I have to install like this, and I have to divide them, and again I have to install this application and this three of the operating system. Even though here one base operating system, guest operating system, on it I have to deploy my application. This is also going to give you a lot of headache while you're setting up the virtualization. Network interfaces are problem, connectivity is the problem, like many connectivities. It is not that simple that we are drawing a diagram and seeing it. But while you're deploying and configuring, it's quite difficult that you're going to face in issues. So these are recorded issues that happening. Okay, now even though virtualization is there and this is happening, then how we can go and do a simplification? So that's how the Docker came into the picture and did the simplification. Okay, and we are calling it as container. Container is nothing but server only. Container is nothing but server only. You can keep it in mind. A running virtual server. Container is nothing but a running virtual server only. Okay, so this container is enabled by the Docker platform by the concept of C groups and namespace. I'll tell you that as well, but let's understand this one and how this Docker is exactly working as like with this comparatively with the hypervisor or the virtualization. Okay, let's come to some of the factor app methodology. When you take some app methodology, what are all the factors that we need to consider? First, a code base. Okay, dependencies matter and configuration matter, and backing services like DB, cache, and attached resources. And we need to build, release, and run. And process is the main thing. While we're executing the app, one or more stateless processes are going to run. And port binding, concurrency, okay, and this is okay, robust for this is nothing but you can ignore it. So you have two types of environment that you can set up for dev and prod and staging and UAT, and logs is always a matter, and you need to get into the admin process whenever you want to do and execute with the privileges. Okay, so these are the factors that we need to consider when an app is deploying into a server. Basically, keeping all this into the mind, and I just want to do into the virtualization and deploy the app and make it run, hurdles are there. Okay, so this is going to be very easy with our containerization. Now let's talk about the container. How the container is look like? It's look like a virtual machine, or a walk like a virtual machine, or a runs like a virtual machine. Nothing is not equal. Okay, it is something that, as I said, it's a running a separate our running virtual instance, a running virtual server. Okay, so its containers are a sandbox inside a Linux kernel, which is sharing the kernel with separate network stack and process stack. So we have two different things comparatively with the Windows and Linux flavor. I'll tell you that. Okay, if you come down, you have this diagram. If you can see, so this is server, this is virtual machines, and these are containers. Okay, when you take a bare metal server and you have the hardware, operating system, bins and libraries, and then you are deploying applications and you're directly connecting to the server. Okay, when you take about the hardware, you have two types of hypervisor, type 1 and hypervisor type 2. We have two types. If you see the type 1, we have hardware, host OS, hypervisor, and guest OS again. Okay, my server is having already hardware, and let's say it is a Windows operating system, and then I have enabled hypervisor with hypervisor V or VMware or something, and then again I have to create a system in it with one more operating system. Now you can take it as a Ubuntu operating system, on it bins and libraries, and then you have to deploy the application. So here what matters? Network interfaces matter, port bindings matter, configurations matter, all these are matter. Okay, so app 1, app 2, app 3, you can run it here. Okay, in type 2 hypervisor, you will be eliminating the host operating system, and you're only going with the hypervisor on the hardware, and you're installing the guest operating system, and then you're installing the application. Okay, so and here you can see the container. Now in the container, in main server is having a hardware, you're just having the host operating system, Windows, Linux or something, and then you are installing a Docker, then it will enable a network in here, and top of that you can running bins and libs and application is running. See, lot of hardware resources are saving in terms of containers. Lot of hardware resources are saving in terms of containers. Okay. So how this containerization is exactly working? See, Docker containers are Linux containers. You need to understand this. C groups is the something that we want to know. Namespace and copy and write, and finally it convert as a containers. So what does mean by C groups? When a server is having the server, Linux is nothing but a kernel. Okay. So there is a kernel feature, there is a group process, control resource, and it's having these some allocations with CPU sets, memory, disk, and block input output. And then the namespace will come into the picture, where it is going to behind the containers, and it creates a barrier between your different namespaces. These are the namespaces: PID, net, IPC, and MNT. Okay, your Linux kernel namespace introduced between these versions. So this namespace is going to create a barrier between these namespaces in order to communicate. And then what happens? Copy and write. So images are not a file system, not a VSD. Basically, it is a tar file with having some arbitrary hierarchy. That's how it is fit into the Docker. Okay, this process we call IXE start, and then we can also equally calculate to the Docker run command. This is how the containerization will work. So whenever you say anybody is asking that what is a container, how the container mechanism is basic, what is the behind the scene it is, then you can say C group and namespaces in the Linux kernel. So that is a base. Based on that only the Docker is developed. Actually, it is the case. Okay. So we know about something about the Docker, and we know about the container. The container is nothing but it is going to run your application. Okay. So if I go and deploy my applications, it will be like this. Docker install, then on top of it you can run your containers. So here your applications will work inside your service will work. Okay, and these are going to associate with your server IP address and then port number. So this is how you are segregating in order to connecting the containers in the same server. IP address and colon port number is just a normal thing that we are discussing technically today. So we'll be having a very deep classes with the labs. Don't worry. With whatever the PDFs I'm showing, you will get all the notes with in detail things. Okay. So once we are ready about the container, and that container we are deploying into a server. Hey, you have 2 or 3 servers that you are deploying, then what about the container? If this container is restarted, if this container wants to move, or if this container wants to stop and start, or the single container is not enough serving the traffic, then I need to duplicate one more container in order to serve the traffic. How do you do a network communication here? all these are matter. So you are not doing orchestration, you're not happening with the management. Okay, you're just only doing the containerization, but you're not able to do the orchestration. So that's how Docker Swarm and the Kubernetes came into the picture. Okay, so this container has to manage, right, orchestrated. So we need to get some benefits. So Kubernetes came into the picture and it is giving you orchestration features. Like whatever all I said, that auto scaling, scaling and self healing and restart kind of features, and your hardware expansion, like server expansion according to the traffic, and the network distribution, like your traffic distribution, is all happens with the your Kubernetes, the short term K8s. Okay, Kubernetes. Even you are deploying this container into this Kubernetes. What this Kubernetes? This Kubernetes is not going to do something inside this container. See, this is my container, and top of this container there is a pod. One more layer is going to enable. So Kubernetes is going to manage this layer, this top layer. Okay, and your container is a runtime inside the pod. So this is how Kubernetes is going to manage for you. And to make a deployment very easy, you have to use Helm chart. Okay. And once you deployed with the Helm chart and your containers and your pods are running, and then you need to do some monitoring. You have to do a Grafana. And in order to establish all these things, you need a Terraform. So let me give you how a real world scenarios are happens with this tool. Okay. When you have a code with your GitHub and you have a developer who is whenever doing the commits, into your source code, and you will be having a GitHub Actions or GitLab CI/CD. Mostly GitHub Actions is into the matter now. So Jenkins is out of, it's slightly moving out of market. So GitHub Actions and GitLab CI/CDs are the current trend. Okay, and now here you will be going to do a CI/CD. Okay, so what happens here? CI/CD will happen. Continuous integration, continuous delivery. CI/CD will happen, and you will be going to have S3 also. So let me take S3 here in order to communicate and do store your things. So you will be having an ACR. So the real world case is very clear. Now I'll tell you with these tools. Whenever you do your CI/CD, so what happens in this CI/CD? So it's going to do a Docker, there'll be a Docker file. The Docker file is going to generate a Docker image. Okay, so let me take an image. So this image is going to tag with your let me take image one. Okay, so let's take like this. So this image is going to generate with your Docker file, and then it is going to upload into your ECR, okay, and we will having a S3. So here you will create the folders, and then this image is going to upload here into two ways. We will be going to use a tools like some of the tools we have already in order to do a scanning. Okay, so what tools we will using the for the scanning, like TryY, uh, CyberRock, and we have many other tools like uh, we do have this one, I forgot. Yeah, so let me do that. TryY. TryY is not there. Let me take the logo of the TryY. So TryY and Aqua, and also we will be having a tool called Snake. So we use Snake as well. So this kind of tools we use for in order to do a scanning. Okay, in order to do a scanning. So in between, this is going to cross, and it will upload here this image with these scannings. Okay, we can use many other tools in order to do a scanning like Sneak Container, Clear, and Answer Engine, Aqua TryY. Okay, all these tools we can use in terms of doing the Docker image scanning in order to find the vulnerabilities in it. Okay, so this is a pre-check that it is going to have. We can say it's left shifted testing kind of thing. Once this image is moved here, if it is finding some of the vulnerabilities, then it will move into another folder, and if it is successful, then it will go into update with updated tag. Always your tag is going to your GitHub SHA ID or a version or a build number. Then this image will be uploaded here, and the same image I'm going to copy. So it is going to present at your copy of your CI/CD runner, and this will be coming to the picture, and then you will be having a cluster. Which cluster? You're having the EKS cluster or something. Okay, so let's say two types. If you I'm just taking the two clusters. Let me take the two clusters here. Let me take the two clusters. So in these two clusters, let's say this one is the production cluster, and this one is the staging cluster. So in staging cluster, or you can take it as a normal cluster, and I'll just say it's a cluster, and I want to use it for 3 environments. Okay, so when you're going to use it for 3 environments, you will be having a dev node pool. You can utilize like that. Okay, dev node pool, UAT node pool, 2 node pools I'm using. Okay, or you can use the same notable and you can do a context with the namespaces. There are two different node pools now with the staging or UAT. Okay, so this is nothing but your EKS cluster or AKS cluster or something. EKS cluster, Kubernetes cluster, which you are going to deploy here, and while you're deploying, the namespace is a matter. Okay, always you're going to deploy with the namespaces, and here there's a Helm coming into the picture. So what happens while your image is done, is created, this is going to be a turn it into a Helm chart, and this chart is also going to upload into your S3 bucket, like this, and this chart is going to apply as a pod here inside your node. Okay, here inside your node it is going to apply as a pod. Here is your cluster. The same thing will happen here as well. The same thing will happen here as well. Copy of Helm is going to be here and here. This is a production cluster. Here, let's say you are running a container inside the pod. You will be a container. Okay, like this. And what happens here? You integrate your prompt TCS to get the all the node metrics. Okay, because in order to monitor you need to integrate that. Okay, so what it will do, it will going to give you everything of your cluster, server, other services. You need to export all these things into this code, into this tool. Then it is going to give you into the some other tool that is nothing but the Grafana. Okay, Grafana. So here will come into the picture of Grafana. So what happens with the Grafana? I have a Grafana here. So my Grafana will be having many dashboards that whatever you want to monitor, so that for that you can actually import your dashboard with your prompt TCS as a data source. It is going to be your data source to your Grafana. It is going to be a data source to your Grafana. Okay, and there is one more thing that we have missed is ArgoCD. So what this continuous delivery tool? It is a continuous delivery tool in order to automate with your GitOps. You can do two things, like it is going to be run by taking a benchmark with your Git or with your S3. So whenever your new Helm chart is uploaded here, so it can fetch with your S3 or Git. So this is always going to find out your drift. Okay, and it is very easy of rolling out and doing the things. It is very easy and it is completely in the GUI mode, graphical user interface mode. We can see all the services, that what are all the things running inside the cluster. You can see it. Okay, production cluster, let me give. Okay, so ArgoCD is going to give you a good UI in order to see all your things. Services, nothing but workloads. Okay, you will be having your Grafana dashboard here, and you can monitor. And what happens if you want to do some alerting? Okay, if you want to do some alerting, you can use tools like PagerDuty in order to do real-time alerting to your Slack channel or to your Teams or your mail, or you can also use Signal FX. With your Splunk, or if you have a Datadog, also you can do that. So these all tools you can keep it up here and do a real-time alerting whenever you find something like your mean time error or your SLO time is breached. Then you can create an alert according to the threshold values, that the metrics that you provided. So this is how exactly the deployment and the monitoring and everything will be happens. And if you do have a Slack or something, then automatically your alerts are going to alert into your channel. Okay, it's going to be alert into a channel effectively. Then the developers or your DevOps engineer, everyone will come into the picture, and then they'll get into the issue and trying to solve it. So all your real-time monitoring will happen through Grafana, because they are the open source and having many dashboards that very easy, making life easy actually. And this is how that the deployment will be happen. We need to make sure CI/CD is something okay, that's done, but integrating workflow and writing some script is okay, generating. But after your deployment, or while your deploying is going on, or after your post deployment, what will be the post deployment actions? Everyone is trying to tell you that we are generating Docker image and deploying, but what happens after deploying? That's also matter. Is the deploying is valid or not? That is giving you alert back to you that the production releases happen properly. Production releases happen and successful message you got in the Slack or not. And then again developers are going to check that in the production the change is reflected or not. If it is not, then we have to revert it back as soon as. What type of strategy that we are using, blue green canary or something, what it is, we have to roll back automatically that whenever the issue is find out. So how the release can be happen, all these are matter in an industry. It's not that easy that in we are learning normally at the other outside platform. So with that knowledge, if you're entering into that, you will get confused by seeing all these tools, integrations, and application deployments, and highly automated with GitHub Actions or GitLab CI/CD. So you need to understand how the monitoring will be happen. See, most of the resources right now, companies are expecting you to work as a SRE. People are already filled it. DevOps support, build and release, and platform engineering. Like they are filling into the platform engineering also. Now the persons are not there with enough resources into SRE, where the companies are looking forward now, because now the things are workloads are deployed, but maintaining is a problem. Things should be drive with AI ops. We need to know something like how to setting up the observability solutions, how to do a deployment after post deployment actions, how to take up them, and how to troubleshoot if it is a production issue happen, or how to drive that a deployment if a if an organization is following a separate, like one is separately building and then get for the approval and do a deployment. So how do you going to take responsibility in those, even though you will get the good KT? Okay, all these are going to done with your uh, Terraform. Okay, so you are setting up and you're doing everything with the Terraform. But I have a question. We have already developed one time with the Terraform, and then why do I need to do Terraform again? I already set up this cluster, ACR, and everything, and again, why do I go for a Terraform? See, even though a small change in your structure, even though a small change at ECR, sometimes you are deploying even through the Terraform itself. Everything is automated through the Terraform right now. Everything. Even though you see is also going to be automated. In some of the organizations, it is like Terraform is only when it is needed for the infrastructure changes, Terraform will be coming to the picture. But always application is separate deployment. So the deployment in two ways. Application deployment is different, infrastructure deployment is different. The actions are running in two different pipelines. But in few organizations, Terraform itself is also application deployment. That the thing what you do also is going to apply through the Terraform actions only. But that's not the case. Most of the organizations, like few organizations, are following like that. So this is how real world structure will look like, and we are going to cover all this. So in this course, so this is how the capstone projects are designed, and you'll get a good understanding in terms of real time data. You will get all the benefits as well. So who are all I think most of the people have missed today, they pinged already, but no problem. You just join every day at 9:30 and do your registration, so that you will get the link automatically and you can continue. And once you completed with your payment, then we'll add you into the group where admin will be take care of you everything, like your practice, and he will be like every time he will follow up you. Okay, so we want the students should be get the good information, and he has able to do and solve himself issues in the real world scenarios. Okay, if you have any questions, that you can ping me over my WhatsApp, and you can ask me also questions from our next sessions. Like from tomorrow there are regular sessions are going to start, and just please don't miss it. Join and start your journey. Anyone having any question? Yeah, sure. Mm-hmm. See, before going to DevOps, you need to just start the basics, networking basics, protocols like what is an IP address, what is protocols, how the application will work, and how the operating system is. These are the very basics, and some Linux basics like how the Linux operating system will be and what are the commands that you day to day you have to run. Okay, so this information is a very prerequisites that you need to know, and then you have to start from the cloud. First, go for a cloud. You need to get some information about any cloud. I recommend strongly AWS cloud. Don't go directly to Azure or don't go directly to GCP. You never get the good subject. AWS is something that you get a raw subject. Okay, so you have to know networking services first thing in the AWS, and then you need to know about the server services like computing services, easy to instance, I need services and all. And then you need to know some other services like load balancer, auto scaling, IAM, and some database services. And then you can come to the DevOps. It is a proper journey that you will get a complete understanding. If you miss this sequence and you watch how many videos over the YouTube or any course, there will be a gap will create in your mind. You won't get it. You are not able to understand, not able to sync the topic to topic. So these are the prerequisites, Bala. N- Not even CCNA. CCNA is something again that the you are deeping into the very deep into the networking from the associate level. But for the DevOps, no need of CCNA knowledge. Okay, you just need some networking knowledge like how the IP address, subnet CIDR works, and types, and how the protocol will connect. This is enough, but in CCNA you will going to learn about the some of the static, EHRP, BGP, EGP, REAP, all these protocols, and some VRRP, all. So that's a different matter again about the routers and all you are learning. So no need of that as well. Okay, here just we need a basic networking knowledge. Too much, it's a good market right now, and still the market is very high. So if you go and Naukari and you just update, you will get a day at least 5 to 10 calls. Okay, so that much market is there in terms of MNC companies, mid-level companies, and startup companies. You might be a fresher or you might be experienced, but you need to create your profile in a right way. People are not creating in a right way and trying to expect the calls from the HR. Now HRs are not doing the job. The job is get done by the AI. The job is get done in the Naukri and LinkedIn itself with the AI models. So the data science is feed like that. So it is just validating your resume. You need to create an ATS, application tracking service resume. You have to, whenever you apply even, that itself is matching, and then that resume is forwarding to HR. Then the HR is calling after A is selected. So we need to create a right profile first. Then we get the good number of calls. Yeah, thank you very much. If anyone having any question, you can open up and you can ask. So course duration is mostly going to be at 20 to 25 days. Okay, and we already having like 18 to 20 students who are eagerly looking for this course, and they are going to be started from tomorrow, and they are going to do a project, and who are all adding into that, we'll be going to divide as a groups, and we will be assigning you the task like project task, everyday task. We create a project dashboard, and there I'll allocate the task that you have to do, and then the admin will come into the picture and he will track always your experiment. So this is how we share the knowledge to our students. Okay, but so this is a special course that you get at only 5,000, and believe me, you will never get outside in the platform this kind of course. So please don't miss out and start your journey from tomorrow itself. It includes Saturday but not Sunday. Sometimes, yes, when we come to the capstone project, yes, we're going to do Saturday, Sunday also. Like project is not going to be done in a one day. Like it long to 2 hours, 2.5 hours. So if at least one project will take 2.5 hours. Okay. Thank you everyone. Thank you very much for joining this course today. It's not like 1 month, it's just 20 to 25 days, and with including Sundays that going to 1 month. Okay. Okay, thank you very much everyone. Just we'll see you tomorrow at the same time. Thank you.